All right, what we're working with today is characteristics of quadratics. We've done several quadratics. Now we're going to be getting into the different forms. The form that we're familiar with is vertex form. And remember, we did these before where this is what shifts left and right. This is what shifts up and down. So you're familiar with those. The new form we have, one of them is standard form, ax squared plus bx plus c. And what happens is you have to identify what the a is, what the b is, and what the c is. And they're just the numbers. So if I have a problem, let's do an example real quick. Y is equal to x squared minus 3x plus 5. My a value is 1. My b value is negative 3. And my c value is 5. Okay, and so we'll learn how that helps us with the graph, but you just have to be able to identify the a, the b, and the c. Okay, the last form that we have is intercept form, and that's x minus p and x minus q. And what it is these numbers inside, they tell us the x-intercepts. So they tell us where they cross the x-axis. Okay, so these are the three different forms you have. We have to be able to graph using all of those three forms. Okay, so there's some key important features that we have to know, and we have to know what it is, where it is, and how you find it. So the axis of symmetry is the parabola's reflection line. If you are snorting this morning, it's my dog. She's a little loud. And so there's my parabola, and then it folds down my reflection line, and that's the axis of symmetry. Okay, the axis of symmetry is from the vertex, and it's x equals whatever the x value is. So it's the x value of the vertex, and you have to remember it's x equals. Let's maybe highlight that as the x value of the vertex. Okay, if you have vertex form, like this first one, it's pretty easy to find because you're able to find the vertex easily. If you don't have vertex form, there's two ways. You're going to do negative b over 2a. Or if you have intercept form, you're going to find the midpoint between p and q. So those are the two ways. I am going to highlight this right here because we will use this a bunch this next chapter and even next chapter. Okay, negative b over 2a. Okay, so the maximum value, if I have a graph that goes down, this is a graph that has a negative a squared. So whatever the a is negative. Then I have a max value. It's right here. It's this turning point. And it's the vertex again. But this time it's how high you go. So it's the y value of the vertex. So again, if you have vertex form, it's nice because you can just find it. If you don't have vertex, you're going to have to do a little work. What you're going to have to do is you're going to have to take the x that you find here, take x value, oops, from the axis and plug in. Because once I know an x value, I can find the y value by plugging it in. So you're going to take this x value and you're going to plug it in. The minimum value, the time you're going to have a minimum is when the curve goes up. So that's a positive a value. And it has a minimum, but it's the same thing. It's the y value from the vertex. And if you don't know it, then you take your x and you plug it in. So max and min, it's one or the other, and you have to remember that it's the y value. Okay, roots, zeros, and solutions are something new that we're going to talk about some this chapter. We'll spend a lot of time next chapter. That's when a graph touches the x-axis. So they look right here. It's where they cross x-axis. The only place that we're going to focus on them is intercept form. It's the P and Q values. So standard form and vertex form, we're not going to spend much time focusing on roots and zeros yet. We will in the future, but for now, intercept form, you have to know how to find those. And look, we have parentheses. And what have I told you 100 times about parentheses? It's the opposite of parentheses. And it's that same rule. Okay? All right, and then y-intercept. Y-intercept, if I have a graph, it's where it crosses the y-axis. Okay? There's two ways to find it. If you have standard form, it's the C value. So if you have standard form, it's the C value. If you don't have standard form and you can't see where it crosses the y-axis, then what you do is you plug in x equals 0 and find y. So there's a couple ways you can find the y-intercept. It's the C value, or you plug in 0 and find out what y is. Okay, so there's lots of rules. Let's go ahead and do some graphing. Okay, so these are the two problems we have to do first. So remember, this is vertex form. So this is telling me I'm going to go to the right 2 and up 3. So that's right 2, up 3. And remember, the A value tells you your slope just one time, and just one time only, and it kind of curves. So my axis of symmetry, let's go back at our notes. Axis of symmetry right here, it says it's the x value. So my axis of symmetry is x equals, well, an x is 2. So it's x equals 2. Max or min, this point right here is a min point, a minimum. So I'm just going to circle minimum. And the lowest it went down was the y value of 3. The last thing I have to find is the y-intercept. I cannot see where it crosses the y-axis, so I'm going to have to do what it says right here, where it says plug in 0 and find y. So I'm going to take my equation, my thing, there it is. I'm going to take this, and instead of x, I'm going to plug in 0. And so I get negative 2 squared plus 3. Well, that's 4 plus 3. So my y-intercept is 7. So it actually crossed right here. I just didn't know it. Okay, why don't you try number 2 on your own, and when you think you have it, press play so that you could check your work. So hopefully you notice that you went left 1 and down 1. So negative 1, negative 1, so right here. This one is my A value of negative 3, so I'm going to go down 1, 2, 3 over 1. Ooh, this one's nice. Look what we found. We just found where it crossed the y-axis. So we found our y-intercept of negative 4. Sometimes that's going to happen. All right, my axis of symmetry, axis has an x, so it's x, and my x happens to be negative 1. And this right here, this is a max point, and my max point is at negative 1. Okay, so these first two are graphs that you should be familiar with because we've done a lot of transformations, so those should be easier ones. Just identifying the axis, the max, min, and the y-intercept, that might be difficult. All right, let's look at the next one. The next ones are in standard form. So the first thing that might be helpful is saying what A is. A is 1, B is negative 2, and C is 4. To find the vertex the first thing I have to do is I have to find my axis of symmetry. And this is that formula that I said that we would use a bunch, negative b over 2a. So I'm going to choose a different color so we can see this. So I'm going to plug it in. So it's negative b, which is negative 2, over 2 times a, which is 1. These two negatives become positive. So it's 2 over 2. So my axis of symmetry is 1. And so this is at 1 also. So the vertex is at 1. Now to find the other value, I'm going to plug 1 into my equation. So it's going to be 1 squared minus 2 times 1 plus 4, which is 1 minus 2 plus 4, which is 3. So my y value is 3. So I'm going to go to the right one, up 3. My a value is 1, so up 1 over 1. And look, I found my y-intercept also. But again, here's another thing. Your y-intercept for standard form, this is the one thing it gives you, which is nice. Your y-intercept is that last number. It's the c value, so that's nice. So my axis of symmetry is x equals 1. I forgot to finish it. This is a minimum point. And so it's at 3. And the y-intercept is at... Okay, so for this one, my a value is negative 1/2. My b value is 4. And my c is negative 7. And so I'm going to do negative b over 2a. So negative 4 over 2 times negative 1/2. So that's negative 4 over negative 1, which is positive 1. So my axis of symmetry is x equals 4. And now I'm going to plug 4 into my equation. And so 4 squared is 16. 4 times 4 is 16. So that's negative 8 plus 16 minus 7, which is 1. And so my vertex is at 4, 1. Now remember, this is a shrink, right? Because it's a fraction. And so whenever you have shrinks, we can't just count our slope. We're going to have to plug in a value to the left or the right. I don't really want to plug in 5 because if I take half of 5 or 5 squared, I'm going to get a decimal. So I'm going to plug in 6. So I'm going to do negative 1/2, 6 squared plus 4 times 6 minus 7. 6 squared is 36. And so that's 18 plus 24. Negative 18 plus 24 minus 7. And negative 18 and negative 7 is a negative 25. So I get a negative 1. So I'm going to have 6, negative 1. And then I do the reflection because here's my axis of symmetry. And I do the reflection on this side. So the max, it's a max value. And the max value is at 1. And the y-intercept, okay, so we need to do a y-intercept in a different color. Or I could look and say, there it is. It's supposed to cross at negative 7. So I could have made my graph a little better. But you get the idea. So the y-intercept is at negative 7. So remember, when you have a shrink, you're going to have to plug in a value to the left or right to find out where that next set of points will be. Split in two because there's a lot of problems. And so what I have here, this is a different form. This tells me that my first x-intercept is at negative 2 and my second x-intercept is at 4. So I'm going to go to the left 2, to the right 4. Your axis of symmetry is right in between those. And so if I count in 1 each way, this right here is your axis of symmetry. This is where the line folds down. And so I just found my axis of symmetry of 1. And what you could have done is you could have added these up and divided by 2, taking their average. And so that's 1. And so since I know that's 1, I'm going to plug it in to find my y value. So it's 3 times negative 3. And so that's a positive 9. So that means this meets way up here. This is a max value, and the max was 9. Now to find the y-intercept, I'm going to plug in 0. So it's 0 plus 2, 0 minus 4. So it's 2 times negative 4. So it crosses at 8. All right, so I'd like you to try number 6, following along with what we did here, and then see what you can find, and then check how you did. So you first sort of found, remember, it's the opposite of parentheses. So I go to positive 1 and negative 2. Well, and here's the issue. You see this? The vertex, the axis of symmetry is right in the middle. Sometimes that happens. And again, I could add them up and divide by 2. So it's negative 1/2. So now to find out the other values, I'm going to plug them in. And so this is 2 times negative 3 over 2. And then this is just 3 over 2. And so I would multiply my top numbers. 3 times 3 is 9, times 2 is 18, divided by 4. So if I reduce that, that's negative 9 over 2. Now, if you feel more comfortable with decimals, you can have decimals. But 2 goes into 9 4.5 times. So this is the same as negative 0.5 and negative 4.5. So I'm going to go down here. And I'm going to make it curve best that I can. This is a minimum value. So it's a min at negative 4.5. And then let's find the y-intercept. Remember, you find the y-intercept by plugging a 0 in. And so I get 2 times negative 1 times 2. And so that is negative 4. And look, I did kind of draw it to do that, but that was luck. Okay, so there's 3 different types of graph. They can be tricky, but the best way to get better at them is to practice and understand what it's asking. Now let's go back to your notes where there was a word problem. You're going to have a lot of word problems in quadratics. You have to understand what they look like. What's nice about it is I'm not going to make you write the equation. Where's my highlighter? You just have to be able to use the equation. So let's draw a little picture of what's going on here. So I have this, and I have someone here who is shooting the ball, okay? And the ball starts here. This is the y-intercept. Well, remember our y-intercept is this last number. So I know that this is 6. You can't see that, so I'm going to put that right there in parentheses. So the ball is going to go up, and then the ball is going to come down. The other point that you need to be able to find is this, which is the maximum point, which is also a vertex. So I'm going to have to do my vertex formula, negative b over 2a. I mean my axis of symmetry. So my a value is negative 16, my b value is 40, and my c value is 6. So it's going to be negative 40 over 2 times negative 16, which is positive 40 over 32, which is actually 1.25. So I know that this is at 1.25. Now to find the other number, the y value, remember I'm going to take that and I'm going to plug this in. And I'm not going to do the math by hand. I'm going to use my calculator. But when I plug that in here, I get 31. So it's important for you to understand what this means. This means that when the ball left the hand, it started at 6 feet up, and then at 1.2 seconds, it reached its maximum height of 31 feet, which is super high for a basketball. So I'm thinking something might be wrong. Well, maybe someone does shoot the ball 31 feet in the air. Okay. The other thing that eventually we'll have to find out is where it crosses the axis here. But right now we're focusing on where it leaves the hand and where the max is. So at 1.25 seconds, the max was 31 feet. So when you're doing all these different types of graphs, it's going to be important for you to remember to look at this table. This table should be helpful to help you find where you find all these pieces, because it is important to understand where these pieces are so that you're able to graph it.